In section 14.3, we're going to talk about averages and moving averages. So let's just jump right in with the material. Let's talk about the average or mean of a collection of values. Again, average or mean of a collection of values is given by y bar is equal to y1 plus y sub 2 plus everything out to y sub n, all divided by n. So you add all of the values and you divide it by the number of values there are. Okay? The average value of a function, which is called the average, that's a V, average or mean of a function f of x on the closed interval AB is given by f bar equals 1 over b minus a times the integral from a to b of f of x dx. Okay, so note that the average or mean of a collection of values is given by the sum of all of the values divided by the number of values you have. And the average value of a function, notice that here you're talking about a collection of values, here you're talking about the average value of a function, is of a function f of x on a closed interval AB is given by f bar equals 1 divided by b minus a times the integral from a to b of f of x dx. So, example 1, we're going to find the average of 21, 75, 80, and 100. So here, in this set, we have 4 values. Well, we are in this case right here. So, to do that, we need to find y bar. Y bar is going to be 21 plus 75 plus 80 plus 100 all over, how many values do we have? We have 4 of them, so we divide by 4. Well, that's equal to 21 plus 75 is 96. 96 plus 80 is 176 plus 100 is 276 all over 4, and divide that, we get 69. So 69 is the average of that set of 4 values. Now, in example 2, we want to find the average of the function f of x equals x cubed minus x over the closed interval 0, 1. So for this, we want to recall the formula for the average value of a function, which was f bar is equal to 1 over b minus a times the integral from a to b of f of x dx. Now for us, a is 0 and b is 1. So we have 1, our f bar is equal to 1 divided by b is 1 minus a is 0 times the integral from 0 to 1 of x cubed minus x dx. Well, 1 over 1 minus 0 is just 1. So you have 1, and we don't even have to write it there, but if you want to, you can. And then we have 1 times, we have to take the antiderivative of x cubed and subtract the antiderivative of x. So we get x to the 4th over 4 minus x squared over 2, evaluated from 0 to 1. And let's separate the recall from our work so we won't get confused there. So now we substitute in 1. That gives us 1/4 minus 1/2. And then we subtract what we get when we substitute in 0. Well, that's 0 minus 0. No fun. 1/4 minus 1/2 is negative 1/4. So that is the average value of the function. That's the average value of this function. F of x equals x cubed minus x over the closed interval 0, 1. Okay? Now, other applications here. Let's look at example 3. A savings account at the People's Credit Union pays 3% interest, compounded continuously, and at the end of the year, you get a bonus of 1% of the average balance in the account during the year. If you deposit $10,000 at the beginning of the year, how much interest and how large a bonus will you get? Okay, so what we want to notice here is, let's just make an observation. So note that we can use continuous compound interest. We can use continuous compound interest because we know it was compounded continuously to find the amount of money we have at time t. Okay, so remember that means A of t, and I'll use a different color here so it'll stand out a little bit. So A of t is equal to 10,000 because that's what we're putting in or depositing at the beginning of the year. E raised to our interest is 3%, so 0.03 t. Okay, now at the end of 1 year, at the end of 1 year, A of 1, using our formula, A of 1 would be equal to, you would substitute in 1 for t, so you would have 10,000 e to the 0.03 times 1, and then you put that into your calculators, you get $10,304.55. Okay, and we can say and we will have earned $304.55 interest. Okay, so that's what we can say. The first question was, so we've answered our first question. It says if you deposit $10,000 at the beginning of the year, how much interest and how large a bonus will you get? So we know how much interest now. So that's how much interest we would get. And then we want to know how large of a bonus. So to find the bonus, we need to find the average amount in the account over the close interval 0 to 1, right? So that means A bar would be equal to 1 over 1 minus 0 times the integral from 0 to 1 of 10,000 e to the 0.03 t dt. Well, that's equal to 10,000 divided by 0.03, okay, times e to the 0.03 t evaluated from 0 to 1. And you might be asking yourself, where did this 0.03 come from? Remember that the antiderivative of the point e to the 0.03t, that's equal to e to the 0.03t divided by 0.03. So this constant could come out of the integral. That's where the 10,000 came from. And then the 1 divided by 0.03 could come out, and that will leave us with this here. So now evaluating, you get that this is equal to approximately, wavy equals approximately $10,151.51, which means the bonus is 1% of this, or in other words, it is $101.52. Okay, if we're rounding up, or $101.51. Okay, there you go. Now, scenario. Suppose you follow the performance of a company stock by recording the daily closing prices. The graph of these prices may seem jittery because of random day-to-day fluctuations. To see any trends and to smooth out, quote unquote, smooth out these data, we can use what's called a moving average. So an n-unit moving average of a function is the following. The n-unit moving average of a function f is f bar of x equals 1 divided by n, because you have n units, and you're evaluating the integral from x minus n to x of f of t dt. Okay, so let's look at an example. We want to calculate the 5-unit moving average of f of x equals x to the 1/3. So notice here we are calculating in the statement an n-unit moving average of a function. You take 1 divided by n. Here with our n is 5. So we are going to have f bar of x, our moving average, is equal to 1/5 the integral from x minus 5 to x of, instead of just writing f of x, we write f of t. So we write t to the 1/3 dt. Well, that's equal to 1/5 the antiderivative of t to the 1/3 is t raised to the 4/3, because you have to add 1 to it, divided by 4/3, your it being 1/3. And then you evaluate from x minus 5 to x. So that's equal to 1/5. Dividing by 4/3 is the same thing as multiplying by 3/4. And then we evaluate t to the 4/3, evaluate it from x minus 5 to x. So that's going to give us 3 divided by 20 times the quantity x raised to the 4/3 minus the quantity x minus 5 to the 4/3. So what in the world does that mean? This is our final answer. But what does that really mean? So it means that we started out with, this is our graph, as our x to the 1/3, and then our final answer, which is the moving average, means it moved it over like that. Okay, so that's a 5-unit moving average of the function f of x equals x to the 1/3. Okay, that's it.